Hello everyone, this is Fahad Mirza and I welcome you to my channel. I'm very excited to share with you this new model from Tencent, Hunyuan Video, which is a text to video model. This model performs as well as, if not better, than leading closed source models. To train Hunyuan Video, they have used several key technologies including data curation, joint model training for images and videos, and a efficient infrastructure for large-scale training and inference. We will be installing it locally and then we will see how it works. The overall architecture seems quite interesting. So what they have done is they have carefully selected and prepared the data used to train the model. They have trained the model on both images and videos to improve its performance. They have designed an efficient infrastructure to facilitate large-scale training and inference. Plus, they have developed a strategy to scale the model, architecture and dataset, which has allowed them to train a video generative model with over 13 billion parameters. So if you look at this diagram, there are few components here. So for text prompt, they have used a model to encode text prompts, which are then used as conditions for the model. They also have used Gaussian noise as input to the model along with the encoded text prompts. And then they have used 3D variation autoencoder to compress the input data into the compact latent space. And towards the end, they have used a diffusion transformer model to generate output video based on the input text prompts and Gaussian nodes. Couple of words on this text encoder. So they have used this pre-trained MLLM or multimodal large language model as their text encoder, which has several advantages over other text encoders because MLLM has better image text alignment, superior ability in image detail description and complex reasoning, and it can also play as a zero shot learner. And then they have used this 3D VAE or variational autoencoder to compress pixel space videos and images into compact latent space, and that has allowed them to reduce the number of tokens for the subsequent diffusion transformer model, enabling them to train videos at the original resolution and frame rate, which is quite cool. So enough theory, let's try to get it installed and see how it works locally. Let me also give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. If you are looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. This is my Ubuntu system and I have one GPU card NVIDIA RTX A6000 with 48 GB of VRAM. Now let's start by first up let me git clone the repo of Hunyuan Video, which you can also access it from Hugging Face model card, and I will drop the link in video's description. That is quite a lightweight, that is good. And then we need to create an environment with Conda, that is highly recommended. Let's wait for it, and the good thing is that they provide an environment file which I'm using. And the environment is created. Let's activate it and you will see it in parentheses on the left hand side. Let's also install GCC compiler in the Conda. The reason why I install it with CUDA is because later we will also need to install few packages which require this. And now let me install all the requirements with pip in the repo. That is done, and now we need to install Flash Attention 2. For that, the prerequisites are packaging and Ninja. Let me install them, and both are done too. Now, in order to install Flash Attention, all you need to do is to run this command so that it will get installed from the source. So let's start it. Next, we need to download the models. In order to download the models, you would need to log into Hugging Face CLI with this command, and here you need to put in your read token from Hugging Face, which is a free token that can be obtained from huggingface.co after logging in. So I have just pasted my token, and then you can see that the login is successful. Now, in order to download the first model, the actual video model, just run this command from the root of the repo. So you see that it is just specifying the 10 cent Hunyuan video, and then it is storing it in this checkpoint. So let's wait for it to get downloaded, and you can see that the actual size of the model is just over 25 gig. Hopefully it will fit on my GPU, but let's see. The main model is almost downloaded, as you can see. It's almost there. There you go. Now we just need to go to this ckpt directory which has been just created, and now here we need to download this text encoder, and this is going to be downloaded here. So you see that it has around 4 shards, so make sure that you have plenty of space here, because there was 23 gig that one, now around 20 gig or so this one. Now why are we downloading this text encoder? This Hunyuan video model uses an MLLM model and a clip model as text encoder. If you remember, I showed you here. So that is what we are downloading now. And for that, we are using this Lava Llama 3 8 billion provided by Xtier, which is being downloaded at the moment. We are also going to separate the language model parts into text encoder after this step. So let's wait for this one to get finished. And that is also done. Let's go one step back, and now let's also download the separate text encoder, which you see is being downloaded in this text encoder directory within that ckpt. This shouldn't be too big in my opinion. Let's wait. And that is also done. Let's go back to that ckpt directory, and now we need to download the clip model. The clip model enables us to understand the relationship between image and the text, and this is a text encoder too which we are using. These clip models are not that huge, as you can see that this one is just under 2 gig. It should be done already. That's done. Let's press enter here, and those are all the models which we needed to download. Let's go one step back. Let me clear the screen. So we have created a conda environment, we have created all the prerequisites and requirements, then we have downloaded all the models including base model, text encoders, clip models and everything, and now we can generate a video from text by the script which they have provided. So in this one, all we are doing it from the root of the repo, we are calling this sample underscore video.py, and then we are giving it that okay, this is a video size, this is the length of the video. Inference step, which it makes iteration to diffuse it and then generate the video. There's a seed, you can do a random or not, and then the prompt is a cat is running realistic. So let me run it, and you can see that it is running. It is going to take a bit of a time while it runs. Let me also show you the VRAM consumption of this model because it is fully loaded. So you see it is consuming just around 25 gig of VRAM. So make sure that you have that much VRAM there. Okay, so let's wait for this one to create, and then I will show you the video. So it is going through all those 30 steps to generate the video. The prompt is this, and it has automatically done its own negative prompting that shouldn't be a real view, shouldn't be overexposed and all that stuff. And the video generation is still running, as you can see, and it's been over 31 minutes. Can you believe that? Just one single prompt, it's fully loaded onto the GPU, and still for just one simple prompt it is taking that much time. It better be of good quality, so let's see how it goes. But I think this is one of the downside, that shouldn't be taking that much time for just one single video generation. Anyway, let's see how it goes. And eventually the video has been generated, as you can see, and saved to this folder. Let me go there. So this is a folder in Hunyuan videos result directory, and if I open it, this is a video. Let me play it for you. There you go. Not bad. Let me play it again. So see, so I agree with the comment that the quality is way better than the previous one. There is still, of course, room for improvement, but I think not bad at all. But I believe that in addition to this, the only thing which is quite a downside is the time it is taking to generate a simple video. I think that should be improved. So that's it. I hope that you enjoyed it. Let me know what do you think, and don't worry about the commands. I will put them in my blog and I will drop the link in video description. Also, I already have covered a lot of Hunyuan models as you can see here. So if you're interested, just search with Hunyuan on the channel and you should be able to find a lot of videos around it. If you like the content, please consider subscribing to the channel. If you're already subscribed, please do me a favor and share it among your network as it helps a lot. Thank you for watching.